All right. So, this one. All right, so objective for today is to finish up 4.4. So first, from what we did cover, I assigned 1 through 20 on, I believe it was 1 through 20 on 4.4. Any questions from any of those? Yes, sir.
What's the calculator shortcut expression? It said to write it out that way. I wasn't really sure what that was.
Okay, so that means, you know how I factored it and
Yeah.
wrote it what I call nested form? And so.
Like number
and then I
7.
did- Yeah, and so what they do with that one, the way they write it is a little different. It's still. it's
They're
still-
really touchy about how you, like, if you put X instead of a dot, it counts it wrong for times. And
Yeah.
Whatever those things on, if you don't got those in the right place,
Parentheses.
parentheses
Yeah.
things, yeah, you gotta have so many of them.
Yeah, well, you.
I did it like
and-
10 times.
I think on this
So in
form,
order-
I typed it wrong.
Yeah, no, and like the first time I did the problem, and it's just one of those deals that,
So you mean the form where we put the brackets in? Like,
Yeah.
Where you take
Here,
the 7
so-
and.
and I'm gonna go work the problem the way they do. I remember, if you remember, I said it's touchy
Yeah.
before you. And the issue with that particular problem is the way that I did it, the way I factor it. And is, correct. I mean, it, you know, and that is using ordered operations. They just arrange it differently, but it's still the same effect. And you have to have all these grouping symbols in there in order for it to work. And it's one of those things I hopefully they will amend it so that you can put it in a little differently. But they have not as yet. And so it's definitely a little touchy on that. And so let's go ahead and.
Oh, and it said it was due the 20th, so like you won't, they won't put it as.
Well-
They won't put it as a late grade.
Yeah, and remember, as always, you can work past any due date. So, without penalty. The due dates are simply there to prompt you to, you know, stay on schedule. Now, it should be said that not all instructors in my department feel the same way on that. You know, that's where you get differences. So if you take another map out somebody else, you know, there are settings I can put in there. You know, I can take off whatever percentage I want for late work. And so you may encounter that in another class. And so it's a preference. And that does tend to motivate some people a little bit more. But I just have a philosophy, we're all adults. And make decisions. So, now, what was the number?
7.
7?
There's a second part of it. And that's the part.
Yeah, yeah. Okay. So on this one, I'm gonna do this first, because what we want to get to is where we're putting it in that nested form in their style. So, boy, wouldn't you like to have this little command? So, there you go. Good, problem done. So let's take a look at it. And then we'll work another one. Right. So in this case, it's number 7, 4.4. And we are looking at 4B, D, A16. All right. So recollect, base 16. Has to have how many digits?
15.
Which is how many digits? 16 digits. So whatever the base is, that's how many digits you have to have. So I was put a little here, capital letters, A, B, C, D. My 0 through 15. So when I actually do calculations, I can look up here and know, what number I'm actually going to use in this case. So the first thing it has you do is write it out in expanded form. Now, 4 times base 16, in this case, second power plus 16, and that would be to the first power. C 16, and that is to 0 power. All right.
You don't put that one in there, it counts it wrong.
It did do for you. You got that one.
And it has to be a dot, you can't even put an X. It's really touchy.
You have to hit the asterisk.
Yeah. Oh, the asterisk.
Or the
Yeah,
asterisk.
the asterisk works, but,
I didn't know that.
yeah.
Now, you can, okay, so here's the thing about the X, which is a standard multiplication symbol. When we rework it, if you go to the toolbar, you'll find the multiplication symbol with the X. You have to use that one. If you use the letter X on your keyboard, it's going to interpret it as the letter X and not the multiplication operation symbol. So you can use that, but you have to pull it off the toolbar. This bothers me because technically it's going to call it a hidden number. It's 1. We don't have to write it. But we understand it's the power of 1. That has to be there as non-negotiable. Now, it says write the calculator shortcut expression for this. All right. And we know the way the calculator shortcut expression would work is to start here, multiply by the what? Base, which is 16. So you get 4 times 16. Then that product, to that product, you're going to add the next digit, which in this case is B. So I'm going to add a what? 11, if I'm actually going to calculation, right? Then I'm going to multiply by the what? Base again, and then add whatever's in ones place at the end. And it's, so which is D, so it's 13. All right. So when I look at this, that's exactly what I can see here. 4 times what? 16 plus 11 times 16, and then plus what? 13. All right. So now, I want to kind of reconcile this. What I showed in class on Monday was I was factoring out what common factors of, in this case, 16. So that's where I was using brackets. And I would say, okay, that leaves me with what? 4 times 16, for the 1 there, and then plus what? This, yeah. And right now, I'm going to go ahead and just say B for now. We'll put them in there in a second. And put my grouping symbol here, and then plus, and that's where I went ahead and drop the 16 to 0 because it's just what? 1. And at that point, I'm done. I mean, other than I could go ahead calculation purposes.
Let's see the problem.
D.
Yeah, it works the same way.
Sorry about that. And so then plus what, 11? And then all right. So when I look at what they have done here, what it really misses the point in doing it this way, and why I keep again, there are other things that Pearson has through the years that I've stated in. I don't think they're changing it just because of me. There's teachers all over the world, but they get enough complaints, and eventually they will change things. It misses the whole fact of what you're doing and factoring out those common factors of 16. It doesn't. The way they write it, it does work, but it misses that point completely. So what they did was actually write it out and then making sure you're using the grouping symbols the way the calculator shortcut works. And that's the difference between the two. So at the end of the day, it's still going to go 4 times 16 plus 11 times 16, and then plus what? 13. But I get that, but again, what I'm doing is factoring out the common factors of 16. They're just saying, okay, 4 times what? 16. And they're writing it left to right. And then since by order of operations, you have to multiply before you add, they don't put the grouping symbol. Now they have to, and they put it over on the right-hand side. And we're just thinking about the right, and that was kind of their intent, but again, it just misses the point of the factoring, so not a fan. All right, good there. And then the last part is to go ahead and actually either way, work it out. And then you can do it this way, or we can do it this way. Either way, we're going to get the same thing, and I'm going to assume they're correct on this, which is 1,213. Okay, so I think they should give you another problem where there's more digits. Okay, and that's what we want to look at next. So here's one of the rare base 16 ones that actually is a little easier in regards to at least this than the other. But once we kind of get the flow, I think we'll be fine. This certainly has more digits. It's got 4 digits. Ooh, that just looks
That
awful.
one took a while.
Yeah.
So it's base 2. So lots of digits. Let's see if we can work this one out. We can work this one out, we can get on any of them, right? All right, so base 2, 2 digits. Now, so what number are we working now? Let's see, I'll try to keep myself here on the board. All right. I'm done with this for now. So number 9. All right, so I've got 1, 0, 1, 2, 3, 1, 2, 3, 4, 5, 6. Ones and then followed by a 0, correct? Okay. Now, base 2. And I don't want, we're going to work out, obviously we have to, because they're asking us to put it in standard form and so on and so forth. However, if for practicality, if I was just saying convert this to base 10, all I would do in my calculator, again, I know that this is 2 to the 0 place. This is 2 to the what? First place. This is 2 to the second place. And because it's either multiplied by 1 or 0, everywhere where I've got a 1, I would just get that power of 2. Which is here, 6 and that, and then just add them up. Okay. And if I was working a lot of base 2, I was actually doing coding and so on and so forth, and asking, I'd have a power of 2 list like through to the 12th, right there. I mean, already multiplied out, so I can know what numbers to grab and add. All right, but unfortunately, we can't do that now. So for you guys out there in the virtual world, we're going to, I'm going to put it on the board here. You can't see there's the one downside. You can't, well, I guess even when we're all virtual, I'd be working on my math. You couldn't really see it there either that well. I'll talk it through it, but I would go 0, 1, 2, 3, 4, 5, 6, 7, then what, 8. So this would be 1 times what? 2 to the 8. Down the line, plus 1 times 2, and that should be 0 times 2 to the what? 7. 2 to the 6. 2 to the 5th. 1, 2, 2. And plus 2 squared. Finally, plus 0 times 2. All right. Then it says, write it out in that calculator shortcut. And again, if you notice what they're doing, is writing it out, kind of going left to right, taking this digit, then times the what? Base, plus the what next digit. And the biggest part here, that we didn't have to worry about here so much, was the parentheses. We're definitely gonna have more grouping symbols here. So let's see if we can work it out their way. Here we go. A little nervous. I think I can do it. So I go 1 times what the base, which is what 2. All right, I can't. I just always use the symbol X. So, what? If it lets me. No. It's got to be, or you got to register classes. Wanting to know if I'm teaching stat anytime soon. So, no. Putting out there. All right. Where was it? 1 times 2, right? All right, now. Got the 2 here, and then we add the what, next what? So that's going to be plus what, 0, then grouping symbol, right? Now times the what? Base. Okay, so times all that. Okay. Then plus what? Next digit, which in this case would be, I'm going to put little, so we don't lose ourselves. Next digit is 1, so I'm going to go plus 1. Okay. Now, at that point, it's times what? 2 again, and it's times the whole thing, right? So I got to have a parenthesis here and what? Here. Good. Then times the what? Or times the 2, then plus the what? Next number. Which is where are we at now?
Third, the 4th one.
So
We just did that.
1 times 2 plus 0. So we did this one, right? That's why I'm putting the check marks here. All right. And so if I go plus the next digit, that's going to be what?
1
Plus 1.
and you need parentheses.
And now, do I need so if I said times 2 all this, then I should be able to add 1 here.
Need parentheses again after this?
So you think I'm gonna need parentheses right here.
No, right after the 1.
Okay,
Like that.
all right. Now, why do I need the parentheses there? Because I'm multiplying that whole thing by what? 2. All right, plus the next digit, which is what? 1. All right. Now, how many ones do I have up here now? 1, 2, 3, and what, 4? So this whole thing times what? 2. Then plus what? This whole thing times what? 2. Then times what? 2 plus 1. All right, so at that point, I've got 7. 1, 2, 3, 4, 5, 6, 7, and now that's the what? 8th one. So I should have down the line 6 on 1, 2, 3, 4, 6. All right, so then times what? 2 And then plus what? Zero. So it's a real exercise of keeping track of everything. And you can see as I was going, I was double checking. This is on the extreme end, for sure. Is it practical to do this? Absolutely not. So I'm hopeful that this is a problem that I'm gonna be able to get amended. So I just don't find it very practical. Other than, it does kind of reaffirm calculator shortcut, and it definitely increases your attention to detail. Now, where is attention to detail going to be really, really important in your lives in just a couple of years? What are you all going to have to do? Education majors, right? Praxis exam, right? And there's a cut score. And you must what, either meet that cut score or exceed it. If you go below that cut score by 1 point, there's no gray area on it. It's got to take it again. So, all right. I should have done the last problem just to, I hope this works. All right, so you see where it says more? If I click there, there's your multiplication symbol, if you so want to use it. If I hit less, notice I still don't have that multiplication symbol there. It's either this one or this one, but either should work if you use it. If you use the letter X off the keyboard, it's going to interpret that as the alphabet letter X. Okay, so expanded form. One, and I don't actually care, like if you were writing it out on a written test, I wouldn't care which one you use. I just prefer that when I'm doing this. Anyway, 2, and then there's your exponential. And this has got to be what, 2d8. Okay. Now, I don't know if this saves a lot of time, but you can do a Control-C and a Control-V and edit. I don't know if that really saves time, but it will work. That's going to be a what, 0. Most of these are 1, so most of these it's just going to be a matter of changing that exponent. Like this one, it's just now type 7. Should have. Seven.
Yeah, this problem is really annoying.
Yeah.
Yes.
Oh my gosh.
I think when I did this, I probably did it wrong 5 or 6 times.
One little typo.
Yeah.
Again, attention to detail. So for sure. All right, 1 turns to. I am not paying attention to detail. Okay. And now we should be at 5. Let's tab over. And now we should be 4. What if it says it's wrong, I may cry, so.
Get 3 tries.
It'd be embarrassing. Too much. And 2. So lots of 1. So I'm not going to take a chance on that. Now the 0 power, that has to be there. The one, that should not have to be in there. That's just a coding issue that, you know, they, a lot of times it is fixed on where you have an exponent of one, but here obviously. That's power of 0. Okay. So I don't think whether you're cut and pasting this or typing it in, I'm not sure one's faster than the other. There's no real quick way to do that other than just making sure you're very detailed. Now, this one is the one that I'm actually concerned.
I figured out, that if you, I mean, I don't know now, but if you use a little caret, it does the up.
Oh, as far as,
Yeah,
yep.
yeah.
And now, is there,
It's like above the number 6 or 7.
yep, well, the number 6 on, so on the keyboard.
Yeah, and
So-
then the star gives you a multiplication symbol.
The asterisk on the which is above the number 8. A lot of times that will indicate multiplication, but like on any calculator like this, the caret key, which is usually above division, that is your exponent. So that does go right along with that. Now, what I would do typing this in is I'd first just count 1, 2, 3, 4, 5, 6, 7. Now I've got to have what, 7 of these? 1, 2, 3, 4, 5, 6, and what? 7. And if you think about it, because that last digit, the ones digit, right, one digit in ones place, you'd never have a parenthesis around it. Oh, you're going to have one less than what the number of what? Well, maybe because we actually have what, 9 digits here, right? And on that first grouping, you didn't have to put a parenthesis here. And then you didn't need one on the end. So I guess it would have to be what? 2 less, assuming I've got the right number of parentheses in here. Okay, so 7 of them. 15, count 1, 2, 3, 4, 5, 6, and what? 7. All right, here we go. 1 times 2 plus 0. Now I can what? Left parenthesis. Times 2. And then plus 1. Close parenthesis.
I highlight that. I'll keep a bunch of time.
That's not a bad idea. Because we know we're going to repeat that right there
5 more times.
5 more times. All right, sounds like a plan. Control C. Cursor right here, so I should be able to do a control V, control V, control V, control V. All right, now how many times did I get it there? 1, 2, 3, 4, 5, and what? 6.
I think it's like 5.
What I'm concerned about.
I think you need one more.
Okay. That gives me my 7th parenthesis. Now I need a times 2 plus 0. Okay. So you definitely, it is detailed on this. But if you can do that one, then you could do what any of them there. That by far is the hardest one. Now, it gets to what is the base 10 equivalent. And again, what I would do, if this were just a practical thing, because it is base 2, I mean, I could certainly go through and add all these up. But actually, if I were doing this just, I wouldn't write all that down. I would have had something like 1, 2, 0, 1. You guys can't quite see here. I'm writing down powers of 2 right here. 2 to the first is 2. 2 squared is 4. 2 cubed cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. And 2 to the 8th, I believe is 256. And so really it's just a matter of adding what? This combination of powers of 2. Okay. And that's what I'm going to do on my calculator. I would need a what? 2 to the 8, so I need a 256 plus, don't need the 128, but then I would need what? 64 plus 32 plus 16 plus 8 plus 4 plus 2, and that is it. All right, assuming I punched all these buttons correct, I got 382. Okay. Not necessarily fun, but we're better at it. All right. Any questions from anywhere? It could be you guys, Maddie, Selena, Denver.
I'm good.
Good. Everyone good? You guys good? Any other problems we can work on? Yes.
Can we do one of the ones that converts to the different bases, like it's in base 10?
Going from base 10 to another base. We're doing all the division, finding remainders. Yep. Sure can.
Last two were like from 7 to 8 and stuff, like 19 and 20. Those are kind of weird.
Yeah, and there's a reason for those.
There's gotta be faster, right?
And there's not.
Oh, really?
Nope.
You have to convert it
That's
to
what I
10
did.
and
That's
then,
what I did.
yeah, that's what I did.
Yep, yep.
Okay, might be faster, but-
Okay,
Yeah.
right here, base 10. Now, at least it's only 2 digits. That does speed things up a bit, but there's a point to be made. Now, it's just a personal thing with me. I am not tech savvy when I say that. What I really mean is I don't care. I have long said I would go back to rotary phones. If you've got right now, just bought a new vehicle, and I have, well, anyway, it's loaded with so much electronics. I just can't. It's overwhelming. I remember once upon a time being able to work on a vehicle.
That's intentional.
Yeah, I think
They
so.
don't want you to be able to.
So now, and I don't, at the end of the day, with technology, it is what it is. I'm a realist. I mean, it's here, it's not going away. I don't care why things work. I just really want them to work, and beyond that. So, but as much technology as I work with, I've gotten, where I have to learn why things work. I'm getting better. I mean, I literally figured out the Zoom thing live here on the fly on Monday. It was the first time I had done that. But so here's a little thing. If you have, this has been around for a while. You guys ever done like file compression on a computer? Save up room on your disk, your hard drive?
Oh, yeah.
Yeah, so you can, you make the computer do it. You go into your settings and go to, and it just says a file compression. Okay, so what is happening there? So remember, everything's base 2. We're going to look at computer language ASCII today, which is again based on base 2. We're going to find out you can convert directly from base 2 to base 16, not have to go through base 10. Now, why would that be? What is 2 to the 4th? 16. There is a what? You can take 2, raise it to an integer power, and get 16. Why can we not go from base 6 to base 8? There is no counting number I can raise 6 to and get the what? 8. And so when I said nope, there is no other way other than we have to go through what? The base 10. So And anyway, what makes that file compression work? Why you're using less space on your hard drive? Because if you go from base 2, which requires a lot of digits, to a larger base, remember it'll be equivalent, just a different base, but you're going to need a lot less digits to do the job, and that's what frees up the space. Okay, so all that said, let's do this one. Oh, no, we're not doing this one. Wait a minute. You asked that. You
Yeah,
already
she has
see it
first.
first.
It's okay. we can-
No, all right, we'll do this one, and then because we're gonna, in the process of doing this one, we're gonna have to,
Technically, it's in that.
yeah, we're gonna have to divert anyway, I apologize. So 32 base 6, and we want to go to base 8. I'm gonna go back to do another one. Okay, so we got base 6, so the first thing I want to do is base 10. So again, fortunately, conversion here will get pretty short. It's just going to be what, basically 18 plus 2 is what? 20, and done. All right, now we want to convert 20, which is in base 10, to base 8. So what we're going to do for algorithm is whatever base we want to convert to, we're going to take that, divide it into the number. Unfortunately, again, the number is very small. I'm not going to have to worry about using my calculator here. 8 goes into 20 twice, with the remainder of 4. And we're done, because this is the end every time. You get to the end here, and you're going to be dividing into a smaller number. So it's going to go 0 times, and your remainder will be that number. And then you read this bottom up. So it's 2, 4, base 8. So remember, when it's written, when you have a number in a different base, don't read it like base 10. Just read the digits and then say the base. 2, 4, base 8. And when I have 20 here, again, that is expressions solely, if I had 382, putting that 100 in there, that is solely due to base 10, because 10 is second to 100, so on and so forth. All right, so 2, 4, base 8. All right, so let's do this one. It'll take a lot of picture. All right, I got it. Everyone got this one down here. I'm gonna erase this masterpiece. Okay. So we want to take 4. So we're looking at number 17. 4, 4, 4. And we're going to say 14,362, and you're going to convert to base. All right, so here we go. Take 3. We're going to divide into 14,362. Right. So unless you are really, really good at arithmetic, I'm not that good. Right. So I once saw a student one time, only one time, and they were just stubborn, really stubborn. We got to the exam. And grades paper exams years and years ago. And they insisted they were going to take the exam without a calculator. So I didn't even have to ask them if they had a headache afterwards. I could see it in their face. I mean, they had a scrap sheet like you wouldn't believe. But I let them do it. Sometimes you just have to let people figure things out for themselves. So 14,362. Now notice before I started this, you saw me what? I double checked. Did I write this down what correctly before I started this process? Divided by 3. Now, you're going to get 4,787.3 repeating. So, which has to be 1. You're absolutely right. So the smaller the number, the easier it is to figure out the remainder looking at the decimal form. If the remainder was 2, you would have 0.6 repeated. And if the remainder was 0, of course, you wouldn't have any decimal at all. Remember, the decimal part of this is the decimal form of remainder over divisor, in this case, 1/3. Okay. So it goes 4,787. Then we write the remainder right here, which is 1. Now, whatever you're dividing by, again, sometimes it's not so easy. Like this case, it was 0.3 repeat. But if you saw a bunch of just random decimals and like, I have no idea, I was dividing by, 16. I don't know what the remainder is. Always take the quotient, which is this, times what you divided by, and subtract it from this. And that will give you the remainder every time. Okay. Then from there, to repeat this until we hit what? 0. All right. So onward and forward. So 4,787 divided by 3 is going to go 1,595 times. And this time the remainder is 2. All right, so 1,595 divided by 3 will go 531 times. Remainder of 2. 531 divided by 3. 177. Went evenly. They remain 177 divided by 3. Also goes evenly, 59 times. 59 divided by 3 goes 19 times, remainder of 2. 3 goes into 19 6 times, remainder of 1. 3 goes into 6 2 times. Sigh of relief because I know I'm at the end because now I'm dividing into something smaller than 3, so it gives 0 times, remainder of 2. All right. Then bottom up. This will be 2 0 1 2 0 0 2 2 1. Base 3. Okay. 2 0 1 2 0 0 2 2. All right. Any other questions? All right. Well, so we got to cover converting base 2 to what, base 16, or directly, what we'll say directly. You don't have to go through base 10. But before we do that, let's do a little math magic. This little number trick I'm about to show you, I don't even know if I don't know, my kids are all grown up and they were never really into cereal to begin with, but I was as a kid. I remember that lots of really bad cereal. Basically, it was sugar in a box. But they used to have all kinds of even games and stuff they put in there and stuff. And this was a game on the back of the cereal box back in the day. So we're back in the 70s. And I actually remember the game. It's called Age Detective. All right, so it don't look like much of a game. But you see table 14 here? Okay, so for you guys out in the virtual world, I do apologize. I can't show you this table we're looking at, but I can tell you it is on page 173 in your e-text, page 173. There's going to be a question about this table in the homework. But let's do the trick. Now, first off, when I first started working here, you can find my age on the table. We need a much bigger table now. You can't find my age at this table. So, but what I need from you guys out in the audience here that can see the table is first off, somebody who is not afraid to tell me their age. Don't tell me. I've said that before. Then somebody will just tell me their age. Point is, I need to tell you your age, but you got to be unafraid of me actually saying your age. All right, back here, got to volunteer. What I need you to do is look at this table. It's got 5 columns, A, B, C, D, and E. All I want you to do is tell me what columns, all of them, by letter, that your age appears in.
A, C.
A, C, and E,
Yeah.
you're 21. All right, you want to try? All right, what columns does your age appear?
C, D, and E.
C, D, and E. C, D, and E. You're 28. Anyone else want to try?
E, D, and I think that's it.
E and D
Yeah.
only. You're 24.
Yep.
Anyone figure out how I'm doing?
The only ones that, it's a combination. If only,
What was I adding up?
I was just seeing that they only. I thought you
You're
just-
adding up.
Oh, you're not looking, yeah, you're not looking. Okay.
Yeah, I'm not looking to find. I'm not trying to find your age down this column. That would be. You could do it, but it'd take a long time. I'm adding up some numbers very quickly. You remember the coin trick? The guy was adding up the powers of 2 plus 88 cents, but there was a lot more powers of 2. Look at the top row. What are those numbers?
Multiple to,
Multiples are powers of 2. 2 to the 0, it's 1. 2 to the first is 2. 2 squared is 4. That's all powers of 2. If you add every one of those up, if you said my age is in columns A, B, C, D, and E, you'd be 31. You would have just added up 1 plus 2 plus 4 plus 8 plus what? 16. So that's all I was doing. When you tell me what columns your age is, I just go to that top row and so you said D and E, and I said, all right, you're 24,
Yeah,
plus
yeah.
16.
yeah, yeah.
That's how the trick works. It's just adding up powers of 2. All right. So what I would need now is a whole nother column and a lot more rows of powers of 2. And basically, the way you construct this table is like so. You see, let's start out. I go. Columns A, B, C, D, and what? E. And we got, okay, 1.
So all the A's are odd numbers, and then B column is just one more than each one.
Well, it kind of, now, as far as that goes, and that is, great observation, it certainly works.
Okay.
But that's not how the table is constructed per se. When I construct the table, I'm literally adding powers of 2. Because I'll go 1 is 1. So like if you were 1 year old and somehow you miraculously you could talk, you'd say I was in column A only. You'd say, okay, you're 1. If you were what, only 2, you'd say I'm only in column B. But if you say you were 3 years old, now I need a 3 in column what? A and what? Because 1 plus 2 is what? 3. Then if you were 4, you'd only be in column C. But if you were 5, you then would need to be where? In A and in what? Now you see how I get to 6. Oh, 6 is what? 2 plus what? 4, right? Continuing on. So to get my age to work, you need a what, column what? F. And then your bottom row would be 63. I am not 63 yet. I'm old as dirt, but I'm not that old. Always said, once if I exhaust out of column F, I'm retired. So, yeah. We good with this? All right. So again, guys, that table that I was referring to for you guys was on page, I think that's it, was 173. On page 173 in the text. Okay, you see the table right beside it. All right, that's the table we need to do our direct conversion. All right, so let's talk about direct conversions. Or what we might say from binary to hexadecimal. All right. Now, I said there is a direct conversion because 2 to the 4th is what? 16. Now, the implication of this is simply this. Every base 16 digit, which there's what, 16 of them, 0 through F, can be represented with a 4-digit binary number. So what we're going to do, I mean, I've got the table right there, right? We're going to get a better understanding of this thing. We're going to build it. So don't look out there. In fact, I'm going to make it turn it. I can't see. Let's build this table. So you've got lined paper, so you may want to make sure you've got 16 entries. Or maybe 17, because I'm going to put page 2. Actually, reverse that. Base 16. And over here, base 2. Now, down here, I'm just going to list out all the base 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Now here, I'm just writing this base because I'll need that when I put together our base 2 column. Okay, so remember, I definitely feel like you're getting the hold of this. I can take any number and represent it as a combination of what powers of 2. And so if every one of these is some 4-digit base 2 number, then what I'm doing is I'm adding up combinations. 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, right? Or what, 1, 2, 4, or what, 8. And there's all the combination is always unique. There's never going to be more than one combination that works here. And where I need one of those powers of 2, I put a 1. And where I don't, I put a what? 0. So the first one is hopefully really easy for you guys. Oh, and you don't have to do this. I need to do this, but just so I don't randomly along the line start getting digits mixed up columns. All right. 1. Now I just need a 1, so it's going to be 0, 0, 0, what? 1. 2. Okay, I need 2 first, so 0, 0, 1, 0. 3, all right, 0, 0, 1, what? 1. I need 2 plus 1. 4 would be 0, 1, 0, 0. Good? You're not good. Say so now. Now's the time.
Why does that make sense? that one.
Because 4 is what, so it would be 0, 1, 0, 0. I need the 4. So I'm figuring out what combination of these added together will give me this particular what digit along the way. So when I get to 5, I would need a 4 and a what? And a 1. So I would need 0, 1, 0, 1. Make sense? So at 6, I would need a 4 and a 2. So I would need 0, 1, 1, 0. 7 would be 4 plus 2 plus 1. So 0, 1, 1, 1. 1, 1, 1. 8, okay, now I need to fuse. So 1, 0, 0, 0. 9, 1, 0, 0, 1. Good. 10, I would need 8 and 2, right? So 1, 0, 1, what? 0. 11, 1, 0, 1, 1. I would need 8 plus 2 plus 1. 12, I would need 8 plus 4. 13, 8 plus 4 plus what? 1. 14, I would need 8 plus 4 plus 2, so 1, 1, 1, what? And then 15 would be all ones, 8 plus 4 plus 2 plus 1. And there's my table. Now, back in the day, you guys aren't going to have to do this. I already said, we'll do all of our tests now on my math statement system. Back when I would give a paper test, we would have a big conversion problem, which I'm going to show you here in a second. We're going to do holy moly. I'd actually always put it up, then we construct this table. So one we got those. But preceding the conversion problem, I would say construct. So again, you don't have notes, you just have to construct the table. Construct the conversion table from base 2 to base 16. Okay, I could do that, but is there a way I could do it faster? We're always looking for a more efficient way, right? Ones place.
Repeat.
Every one, right?
That's
0, 1, 0, 1, 0, 1, 0, 1. Go down this column, 2 to the first place, 2 zeros, 2 1s, 2 zeros, 2 1s, 2 zeros, 2 1s. 2 to the fourth, 4 zeros, 4 1s, 4 zeros, 4 what? So there's a pattern way to construct this table rapidly. You've got to construct it by hand. Now, you do know that it is on page what? 173 in the e-text. I've shown you that. But what they don't show on this, because so in theory, as long as there's a direct conversion, say between base 3 and base 9, we're not going to do it. There's no practical use for it per se. But because 3 squared is what, 9. So every digit of base 9, 0 through 8, can be represented by some 2-digit base what, 3 number. But there is actual practical usage. 2 and base what, 8. And there is a direct conversion because 2 to the third is what, 8. Now, what the implication is, every base 8 digit, 0 through 7, is somewhat 3-digit what, binary number. So once you have this table, you can actually put a little table within a table. And you've got your what, base 8 digit setting there, and they're 3-digit equivalents. Okay. So now, again, normally the way I would introduce this particular direct conversion topic is I would, now don't write this down. Please don't write this down. Just watch. And I'm literally making this up. I stopped because I ran out of room. And I'd say, okay, this is gonna be a problem just like you have on the test. And this would exactly be like the problem you have on the test. And it would say, convert this to base 16.
Take each block and
Take
Right
each
there.
4 digits.
That's it exactly. That's how you do it. Once you've got this table, there's no, you don't need capital to do this problem. But if you didn't know about this, you would think I'd have to go to base what? 10. Oh, I'm just curious. How many digits do I have? Place value wise. 0, 1, 2, 3, 4. $39. That is 2 to the 39th place. I'm just curious. If I figure out just that one place value. I don't even know if I've got all the digits because I had to put it in scientific notation. It was 5.497558139 times 10 to the 11th power. That's just one place value. Can you imagine converting that to base 10?
Be the whole super.
Yeah. So obviously my intent in constructing this problem on the paper test was the only way to do it is by knowing what the shortcut, how to go to convert directly from base 2 to base 16. So what I do is since every four base 2 digits forms a base 16 digit, start at one's place, first go every 4. And put a big old partition there. Why would I make it exaggerated? I don't want to confuse it with a what? A 1. And then just down the line,
About the leftovers, if they're-
then remember we can have, well, we've never talked about significant digits, but if we
Oh, I
get
know.
down here, you just have 2 more zeros. So you can be like one of these guys.
Okay.
Good question. Yeah. I just got lucky there. Not sure why that worked out. I may have miscounted.
So they say 39 is not divided by 4.
Oh, no, it's 40, because I kind of remember I started 2 to the 0. No, I was right, 2 to the 0. It's not, that's not beyond me, not to, I can easily miscount. But yeah, that's right, because there would be 40 digits.
So if there is more, you just put zeros in front.
Yeah,
of
you
it.
just have zeros in front of it. Okay, exactly. And now it's just read the table. I mean, you don't even have to think about it. I mean, you can do this without the table. You're just having it in your head, what convert each one as you go. If you got the table, it's just find it over on the table. So that would be what? A. This one would be what? E. The next one would be the D. I'm gonna let you tell me. Oh, that's E. This one's gonna be A again. Correct?
Yeah.
Okay. This one is what? B.
9.
And A. B. D. 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 And then you can attach a 16 and done. So what on the outset looked like an impossible problem actually is not bad at all. And the ones in my math lab, I'm not sure. They're not anywhere exaggerated like that. Okay, we good with that? And there will be now, what if I had to go back the other direction? What if it said go from base 16 to base 2? You would start here and represent that with a what? 4-digit equivalent. Just one, you're just going directly and backwards. Good? All right. Okay. So I don't believe they actually talk about this in the text. Probably within the problems. Just looking at the text, but yeah. So much the same, but ask it. I promise you, we talk about the computer code. Ask it. So in reading this, this is number 27 in the homework. Notice it does explain what ASCII is. It's an acronym. American Standard Code of Information Interchange. I think it's very worthwhile to look at this, considering how absolutely hooked. I was thinking about it last night as I was had the World Series on. Anyone, any baseball fans out there? Did you hear about the game last night? The pitcher. I'm a Reds guy, so yeah, I'm sad.
As long as the Astros lose,
Well, they lost last night,
good.
but it's going to be a very difficult series for the Braves to win. They only had 3 starting pitchers coming in, and they lost one last night.
Keep those arm out.
Worse than that. You talk about tough. This is tough. This is beyond tough. He took a 102-mile-an-hour line drive off his
Me,
shin
oh.
right here.
Break it.
Yeah, cracked the fibula. Wow. Yeah, so he gets hit with the line drive. No outs. He strikes out the first out and the last out, and the last out was a 2-2 on a curveball. And when you saw him plant that leg, it just you knew something wasn't right. But he still finished out the inning, and he apologized for having to be pulled out of the game. He literally pitched on a broken leg. I would have crawled off crying, I think, so I'm honest with myself. Anyway. Yeah, I was sitting there watching the World Series, and it's because it's baseball, and I'm a baseball guy. I'm looking at Facebook videos, so scrolling through. Look on technology. All right, so what is ASCII? So if we read here, it says we take 26, right? 26 letters to our alphabet. Capital letters A through Z are assigned now in base 10. They're assigned the numbers 65 through what? 90. That means A, 1-to-1 correspondence. We're talking about set stuff now. A corresponds to 65. B corresponds to 66. That is capital B. C corresponds to what? 67. Turns out if you convert all these numbers, 65 through 90 to base 2, they are all 7-digit what? In binary, there are 7 digits. Which means it's what a combination of what 1 through what? 64. So A, which has to be what? 65. In ASCII, it has to be 1 0 0 0 0 0. You don't put the TWO, but it is still base 2. But that is the ASCII code for the capital letter what? A. That's just for the letter A, the capital letter A. If I spell the word cat in caps, it's going to take 27 what? Characters to make that happen. Just the word cat. You kind of get the point. So if say you take a 4-page research paper on a famous mathematician and convert it to what ASCII, can you imagine what a mess that would be? And then you've got all the what? Punctuation. So again, I was talking about, I did talk to you about Hitchhiker's Guide, right? 42. And 42, what it corresponds to is an asterisk. And in coding, an asterisk is called a wildcard. Is what their wildcard. So if you're coding, you put a wildcard. What it means is, again, what it directly translates is whatever you want it to be, because it's a wildcard. What is the whole answer to life, universe, and everything? Whatever you want it to be. So when you do this problem, it's, just remember, it is just converting, figure out, the hardest part of the problem, honestly, is making sure you know what number in base 10 that letter corresponds to. Once you've got the number, it's just convert to what base 2. It's just simply a conversion to base 2. So like A is easy, 65. M, however, where you, anything right in the middle there is gonna, you're gonna have to think about it. Notice the lowercase letters are what? 97 through what? 122. Somewhere buried in a filing cabinet in my office, I actually have the entire ASCII code list for everything. But so that actually, notice this one, this problem is what for the smaller case what? Okay, now little a is 97. Little b is 90 what 8, and you get the point. I mean, you're gonna have to what? Yeah, all the way to k. So however you want to figure out to do that, just make sure you've got the and technically, again, if it's asking, you don't have to put the TW where it says they've got it. Okay, so your homework for Tuesday, Monday is to finish up 4.4. So I'm what did I put the due date to be?
Like last week, a week ago today. It doesn't matter, I just.
Oh, yeah, I guess I did.
I was gonna count later.
Well, I have the power, however, to, this is one of, and normally I'm able to make an assignment to say do the whole thing, but sometimes I do like today with this, it always takes 2 sessions, so. Monday will be the first, I think.
Yeah.
So I'm gonna change that due date for this to be 11/21. And again, it doesn't matter, you can always work past due dates with more penalties. It's just, again, for pacing purposes. So I went ahead and made that for Monday. That's your assignment. You guys out here, make sure if you have not sent 3 names to me, make sure you do that. So in terms of selecting a mathematician to research. So, and again, the paper is due the last regular scheduled class meeting of the semester. Right?
So 4.4 is due on Monday now?
Yes, ma'am.
Okay, thank you.
Yeah, I just, again, it was, I had to sign part of it. So I went ahead and just changed the due date, for the whole thing. So, all right. All right, gang, be safe. We'll see you Monday. Have a great weekend.